Okay, so just trying to pull the data over. I'm putting it in Google Sheets. You can just open it in Microsoft Excel if you want, but I'm on a Mac, so I don't have Excel easily to get to. So Google Sheets is just easier. Um, let's see. So we got in the tabs down below, there's default versus credit score, mortgage versus income. We've got, what else here? Home value versus income, equity versus FICO scores. You don't necessarily have to know what these things mean in order to get the right scatter plot. But it looks like there's 5 different data sets. I think our job is to figure out which data set goes with it. So with mine, I'm looking at the x-axis, and I'm thinking that my data is somewhere between like 9 is the lowest on the x-axis and 60 is the highest. So that could be, what are we on here? That could be debt to income ratio. That could be debt to income, could be the x-axis, because these numbers look like they're between 9 and 60. Let's see if that rules out some other ones. Like, look, this is definitely not between 9 and 60. This is not between 9 and 60. So equity versus FICO is definitely ruled out. These are ruled out. Those are way too big. These are ruled out. Those are way too big. Let's see. So this one is between 9 and 60, but look, the highest number we have here is 16.7. On the x-axis, the highest number we have is like 59. So without even making the scatter plot, I can just look at the range of the values for each of the columns, and I know it's got to be debt to income and loan amount. And the debt to income ratio, wait, I think that's what this is. Yeah. The debt to income ratio is on the x-axis because those are the numbers going across here. Oh, I think I have to click start. Okay. What variables are you using in the scatter plot? Debt to income and loan amount. Otherwise, the other way you could do it is you could just make 5 individual scatter plots, but that takes a little longer. What is the direction of the correlation? So if you see a bunch of dots that are moving up in a straight line, then it's a positive correlation. Read it from left to right. And if you read it starting on the left, reading to the right, and the dots are going down as you read it from left to right, that means it's a negative correlation. This one, I can't really tell. I mean, if I was to draw a line, just one straight line through this data, I think it'd be a flat horizontal line. I think there's no correlation here. And what's the strength? I'd say no correlation again, because since there's no line, there's no strength in a linear relationship between the data points. If the data were making like, here, maybe I can do another variation of this problem after, because I think it gives you, it randomizes the choices. So we'll come back. I'll show you some other examples. But a strong correlation is when the data points are really close to a line. A weak correlation would be if the data points are forming a straight line, like a line that's going up, but maybe the dots have a lot of scatter in them. Okay. Still in the same challenge activity. Looks like we got to download. It says create a scatter plot using the data in the spreadsheet linked above. I don't know. I mean, isn't this the same data set? Yeah. It says, what is the equation for the regression line that predicts selling price versus using household income as an explanatory variable? So let's go over to selling price, this tab that has home value and selling price in it, because they're asking us to predict selling price using household income as the explanatory variable. What that means is household income is our X variable. That's the explanatory variable. That's what's causing the change in the relationship. So when you calculate the slope of the best fitting line, you type in equals, type in slope, and the same thing with Excel too as in Google Sheets. Open a parentheses, and it's weird. It wants the Y values first in Excel and in Google Sheets. Y value first, comma, X values. So I'm going to click and drag these ones. And then close the parentheses. So that's the slope of the line that best fits the data. That's like m and y equals mx plus b. We also need the y-intercept. type equals intercept, open parentheses, and again, it's got to be y first. So you can click and drag and put a comma, and then you can click and drag for the x column. I think that's everything we need. Oh, I don't like that they don't tell you how many decimals to use. Usually software like this does, but so we'll do 6.382591486. I'm just typing in all the decimals. -164242.7799. What's the interpretation of the slope? With linear regression, a slope tells you how many y values you go up for one increase in the x value. So in other words, our y value is the selling price. This slope of 6.382 says that the selling price goes up by $6 for every $1 increase in household income. Okay. So since it's a positive slope, selling price is going up, and the household income is going up. If the slope was negative, what that means is the y variable is going down as the x variable goes up. Okay, so just to repeat that distinction, I have a positive number for my slope. So that means selling price goes up when household income goes up. If I had a negative slope, then that means my y variable goes down while my x variable goes up. And what is the interpretation of the intercept? The intercept is, there's no practical interpretation here, because what the intercept is it's the value of the y variable when x equals 0. So it's the value of the selling price of the home when there's no household income. That doesn't make much sense, right? The home is not worth negative $164,000, so there's no practical interpretation there. Okay, so I gotta pause the video because I'm actually not sure if my audio is recording.